Hello friends, my name is Dr. Mohd Umar and I am Assistant Professor in the Department of Civil Engineering, B.S. Abdul Rahman Crescent Institute of Science and Technology. Previously we were studying about friction and we have solved a problem. But I feel that while solving two block problem, you might be facing some difficulties, and hence today I have came with a trick to solve two block sums easily, and that's why I have made a title over here: two block sums made easy. In this video we'll be learning about the steps to solve two block sum. Then we will see the tricks to solve two block sums, and then we'll solve a problem, we'll solve an example, and we'll learn how we can easily solve a two block sum. Okay, so we'll move ahead with the steps to solve a two block sum in friction. So first, what we need to do, we need to draw a two free body diagram. The first step is to draw a free body diagram. I hope you know how to draw a free body diagram. Let us see. If we have a block over here, then the weight of this block will be acting downward. Let us suppose that weight can be set as W, and since this block is in equilibrium, and hence an equal and opposite force will act upward, and that force will call it as normal. Similarly, if suppose a force which is acting on the block, let us suppose that force, we can name that force as, let us suppose that force as P, we can name it as P. Then if suppose we have a surface which is not smooth, then a frictional force will act in the opposite direction. Let us suppose that is F, and this is your free body diagram. The second step is to resolve the forces if it is required, and the third step is to apply conditions of equilibrium in 2D. So we have condition of equilibrium as sigma F x equals to 0, and we have sigma F y equals to 0. So with these steps we can easily able to solve a two block sum. Let us move further. Let us see the tricks to solve two block sums. The first thing and the most confused thing when we are coming with the two block sum is that if suppose we have two blocks, let us take an example over here so that we can able to understand it more clearly. So we have a surface which is rough, and we have one block, and over it we have one more block resting, and a force P is acting on the downward block. Now the most confused thing over here is that where the frictional force will act, let us suppose if this block is A and this block is B, what will be the direction of frictional force for block A and what will be the direction of frictional force for block B? So this is the most confused thing. So let us make it easy. So I have some trick for you. So the block on which force is applied will get the friction in the opposite direction of force. So let us suppose we have block A. If we are going to make the free body diagram of block A, this is my block A. So if we are going to make a free body diagram of block A, so we will have W, which will be acting downward, and will have normal, which will be acting upward. Now if force is acting P, then the frictional force, the direction of the frictional force will be opposite the force acting, and that is F. And the other trick is that the other block will get the friction in the direction of force. So the block B, if suppose I am making a block B over here, and the free body diagram I will draw for the block B. So let us suppose this is block B, and we are going to make the free body diagram. So over here we will have weight of the block B, and a normal force will act on block B, and the frictional force will be acting on the block B. This will be along the direction of the force. And the third trick is that start solving the top block first. So this will make, if we wanted to make solve two blocks easily, we have to start with the top block, which means that in this case we have block B. So we should start with by solving block B first. Okay, so let us move further. So let us take an example. This is the example number 9 of our tutorial of module 4. So we have a block of 5 kg which rests on block of 10 kg and is attached by a horizontal rope. And is attached by the horizontal rope. So let me make it a bit small. Okay, so on the wall, so we can see here we have a block of 5 kg here, and we have a block of 10 kg here. Block 5 is being attached from the wall with a rope. What force F is necessary to cause motion of A to impend? So here, what is impend? We have already studied before. Impend is nothing but it is the condition or the state when the state of the body is changing from rest to motion. Okay, so this is the in between state. This means that in the question it is being asked to find the force which will make the block of 10 kg just to start the motion, not to be in the motion, just to begin the motion. That is called impend or impending motion. The coefficient of friction between two blocks is 0.2. So here what is given in the question is that here we have mu is 0.2 and between block and other floor is 0.3. So here we have coefficient of friction as 0. Here mu we have 0.3. Okay, so as the step says, first we have to draw the free body diagram. So let us move to the full screen. And now we will draw the free body diagram of each block. So first we will draw the free body diagram of 5 kg block, and then we will draw the free body diagram of 10 kg block. Okay, so what will be the first case? will have 5g, which means that the load of this block will be acting downward, and to balance that we'll have N1. Let us suppose the normal force for block 5 kg can be named as N1, which will be acting upward. Then next, what force will be acting? We'll have a tension force because of this string or thread, you can say. A tension force will be acting in this direction, and we'll have a frictional force. Since we are pulling this block, this block will try to move in this direction. This block will try to move in this direction, and the above block will resist. Okay, so hence this block will experience friction in this direction. Because this block will not move, this block will try to move in this direction, and hence it will experience friction in this direction, and hence we got a friction here. So this is the free body diagram of block of 5 kg. This is 5 kg block. Okay, now we'll draw the free body diagram of 10 kg block. So this is 10 kg block. Let us try it over here. This is 10 kg block. So the weight of the block will be acting downward. 10g means 10 times of gravity, and the normal force will be acting upward. Let us take the normal force of block 10 kg as N2. Now we will have force F, which is already acting, given in the question. Okay, now here the question is coming, where will be the frictional force acting? Okay, and how many frictional force will be acting on this 10 kg block? Okay, so let us see that. So we'll have a force between this ground and the block. So that frictional force will be acting opposite to the motion. So this will be your F2, and one more surface will have this surface also. So these two surfaces between 5 kg block and 10 kg block will also give the friction, and that will also act opposite to the direction of force, and that will be your F1. And one more thing we should not forget. Since this block 10 kg block is 5 kg block is kept over 10 kg block, and hence weight of this 10 kg block will be acting downward, and that we can take it as N1. Okay, I hope this might have cleared you that why this F2 friction and F1 friction is coming for 10 kg block, and why only F1 friction is coming for 5 kg block. Since 5 kg block is having only one surface in contact, it does not have any contact from the top, it has contact only over here, and hence he has got one friction force. But the 10 kg block has a contact, one from the ground and one with the 5 kg block, and hence it is getting two frictional force. One is F1, other one is F2. This will be the same force, only the direction will change. This force F1 will be same, only direction will change, same as this force. Now let us make this 5g. This 5g is nothing but 5 into 9.81. Let us calculate this and write the value. So 5 into 9.81 will give you the value of 49.05 Newton. This value we can use it further. Similarly, 10 into 9.81 will give you 98.1 Newton. This value also we can have for the calculation. So let us begin to solve the sum. One more thing I would like to highlight over here is that this free body diagram is very important in order to solve any block sum. If you fail to draw this free body diagram properly, it is not possible for you to solve the sum, and hence it is very important to draw the free body diagram properly and to understand the concept why the frictional force and where the frictional force will act. Okay, so this is 5 kg free body diagram of 5 kg block, and this is free body diagram of 10 kg block. Okay, so let us start solving. So we will first solve the 5 kg block, which is top block. Okay, so let us write F1 first. Okay, what is frictional force? We know frictional force is nothing but mu into n. Okay, so what will be F1 over here? What will be F1 over here? Will have mu into n1, and we know that for mu for this surface is nothing but mu is 0.2, and mu for the ground surface we have as 0.3. It is given in the question, so we can have F as 0.2 n1. Okay, so let us keep this as an equation first. Okay, and now we can apply the equilibrium condition. Let us apply sigma fx equals to 0 first. So we have in x direction we have force F1, we have T. Okay, so then we'll have T is equals to F1, which implies that T is equals to 0.2 n1. Let us keep this also with us. Now we'll apply sigma Fy, second condition of equilibrium. Sigma Fy is equals to 0. So we'll have this n1 and we'll have this 5g. This 5g has become over here 49.05, that we can write over here. So this is in Newton. Okay, and this has become 98.1. So this also we can write over here 98.1 Newton. Okay, now in this condition we'll have n1 is equals to 49.05 Newton. So we got the n1 value directly from this equation. Now we can put this value in this equation and the above equation. We'll get the value. What we will get over here? We'll get the value of T as T is equals to, if we'll solve it, we'll get the value of T as 9.81. Okay, let us verify it. So we have 49.05 into 0.2, we'll get the value as 9.81 Newton. Similarly, we'll get the value of F1 as, let us make this under box. So we'll get the value of F1 as 9.81. So we can just write over here. Okay, just give me. Okay, so similarly we'll get the value of F1 as 9.81 Newton. Okay, similarly with this we have got the value of F1 and we have got the value of T over here. Now we can solve for block 10 kg. Okay, so initially we were solving for block 5 kg. So this we were solving for block 5 kg. Okay, This we were solving for block 5 kg. Now we will solve it for block 10 kg. You may name it as A and B also for better clarity. So let us suppose this you can name it as A and this you can name it as B for better clarity and to avoid any confusion. Again we'll apply sigma fx equals to 0 over here. Again we can apply sigma f equal to 0 over here. So what we will get, we'll have this f, we'll have f1 and we will have f2. So we don't know f, we can write over here f equals to f1 plus f2, but we know f1 but we don't know f2. What will be f2? Here we can write f2, f2 will be mu into n2, but we don't know what is n2, but we know mu. So f2 is equals to 0.3 n2. So this, for now we can have this equation for now. We can have this equation for now. Okay. So now this can become, this equation can be written as 9.81, value of 1, this is 9.81 plus 0.3 n2. Okay, so this we can have it for now, this we can have it for now. Similarly we can go and find this. We can apply the other condition of equilibrium, which is nothing but sigma fy equals to 0. This will give me n2, n1 and 98.1. So we can add. So n2 is equals to n1 plus 98.1. This will become, we know the value of n1, so that we can put this. So n1 is 9.81 plus n1 is 49.05. we have n1 as 49.05, sorry for that. So we have n1 as 49.05 and we have 98.1. so if we will add these two, we will get the value of n2. So the value of n2 will be 107.91 Newton, and hence once we'll put this in the above equation, we'll get the value of f, what is required. So f will be equals to 9.81 plus 0.3 into 107.91. This will give me the value of f as 34.335 Newton. So I hope you would have understood it easily and you have got the trick to solve the two block sum, which is very easy. I hope you would have liked this video. If you have any doubts, you can always reach out to me. Thank you so much for your patience listening.